Łaziska Power Plant, included in the group One Production, is a facility on the Polish energetic market, leading in the scope of testing and implementing modern pro-ecological technologies. Between 1997 and 2000, there was a modern installation of wet flue gas desulfurization based on a wet lime and gypsum method constructed in the Łaziska Power Plant. In 2010, the construction of an installation for reduction of nitrous oxides with the method of injection of ammonia water to boiler fumes was started. Continuing the works over reduction of impurities emitted to the atmosphere, in spring and summer 2014, a verifying installation for measurements and trial reduction of mercury emission in flue gases from boiler number 12 was constructed. The use of coal for energy generation is connected with more and more stringent emission requirements. Soon enough, mercury will become one of the substances along with emissions that should be reduced. Therefore, to meet the concerns, One Production, in cooperation with the AGH University of Science and Technology in Krakow, the Institute for Chemical Processing of Coal, and the Central Mining Institute, built a system to capture mercury in Łaziska. It was commissioned in June 2014, and soon we will begin research in this facility. The installation was financed with the means of the Knowledge and Innovative Communities InnoEnergy, the European Initiative, the European Institute of Innovation and Technology in Budapest, and with Toron's contribution. The purpose of all these actions is to significantly limit the nuisance of chemical processes taking place during the procedure of the burning of hard coal for the natural environment. And the experience of a long-standing scientific examination program realized by One Production, together with the University of Science and Technology in Krakow, will be used to plan future pro-ecological investments. Mercury and its compounds, used for various purposes, have accompanied man over the last centuries. Today, we commonly acknowledge that mercury is toxic. We try to eliminate it as much as possible. Mercury is also present in coals, to a lesser extent in hard coals, and to a larger extent in lignites. In both cases, however, these are trace amounts. However, taking into account the scale of the use of coal for energy generation purposes, in simple words, for coal combustion, the emission of mercury into the environment may already be significant. Our share in global emissions of mercury from coal combustion reaches 4 to 5%. The largest sphere of mercury emission to the natural environment is Asia. It is a region of dynamically developing industry, however with limited respect to the natural environment. Second and third place, for similar reasons, is occupied by Africa and Southern America. Mercury emission in the European Union is estimated at a relatively low level, but if we assume an absolute quantity of this emission, it turns out that this value is significant for the health of the people who live in Europe. In the balance of mercury emission to the natural environment, the highest part is held by gold extraction on a lower scale. Second place is occupied by coal combustion, and this covers almost a quarter of the entire mercury emission. Two further significant roles in mercury emission to the natural environment include production of non-ferrous metals and cement. The participation of Poland in the emission of mercury to the natural environment is continuously decreasing thanks to modernization of our industry. In the 1990s, it was almost 30 tons per year. Currently, mercury emission is estimated at the level of about 10 tons per year. The installation for measurement and capture of mercury collects flue gases from the exhaust fumes channel of block number 12. The installation possesses a system of dosing absorbents. These substances cause various levels of mercury precipitation and reduction in flue gases. The scheme presents the arrangement of connections between separate elements of the installation. A computer model comprises all of the major elements of the technological chain of flue gas purification. The effectiveness of the reduction of mercury emission depends to a significant extent on the form of its presence in flue gases. Mercury is present in three chemical forms: gas elementary Hg0, gas bivalent Hg2+, and binded with dust Hgp. During the combustion process, mercury evaporates mainly to the elementary form Hg0. As a result of flue gases cooling and a reaction with other components of fumes, elementary mercury transforms into an oxidized form, Hg2+, and this may be absorbed on solid particles. Regarding the form of mercury presence in fume gases, there are various methods of reduction of this impurity. Volatile elementary mercury Hg0 is insoluble in water, therefore it is not absorbed in the suspension of the absorber. Elementary mercury is absorbed by living organisms, for example fish, and, moving along the food chain, by people. In turn, the contact of mercury comprised in the fume gases with volatile ash provides an opportunity to oxidize elementary mercury to the form Hg2+, which is inclined for sorption on solid particles and may be removed with absorption methods. Oxidized mercury Hg2+ may also react with sulfides present in fume gases in the form of mercuric sulfide HGS. It is precipitated from a wet suspension in the form of a sediment, removed in the process of fume gas desulfurization. The process of oxidation of elementary mercury to gas form also takes place in the system of catalytic reduction, which supports the effectiveness of its reduction from flume gases. Thus, regarding the form of mercury applied to systems of gas purification, there is a possibility to achieve various levels of effectiveness in mercury emission. The installation will serve to monitor the emission of mercury from flue gases and to capture and determine mercury in flue gases with a special sorbent injection system, where sorbents from the activated carbon sorbents to the mineral sorbent will be injected. The principle of operation of the system consists of injecting a powdery sorbent into the flue gas stream, which is possible in variants in different installation points. For example, at the front of or behind the electrostatic precipitator. Porous materials with a property to absorb mercury vapor and mercury compounds from the flue gas stream are used as sorbents. The system for monitoring and reduction of mercury consists of a 3-zone electrostatic precipitator, a sorbent injection unit, a fabric filter, and a fan which allows the release of exhaust fumes in the amount of 3 to 7,000 cubic meters per hour. The size of this stream was selected in such a way that it is possible to transfer the obtained results to the actual exhaust after-treatment systems working in the power plants. The ability to reduce the amount of mercury, which is extremely important from the environmental point of view, requires the measurement works to be conducted, that is, the analysis of mercury. It's not just about analytics, as the determination of total mercury, but also about its speciation, which means the determination of different forms of mercury. For example, in the exhaust gases, which are the subject of our research, mercury is present in several forms, with a 0 oxidation state and with a +2 oxidation state as well. Knowledge of these concentration forms of mercury is crucial for the efficiency of mercury removal from exhaust fumes. The ability to access real flue gases, which are virtually impossible to be produced or created in laboratory conditions, will definitely help us to render the task of determination of forms of mercury. The installation constructed in the Łaziska power plant was made from the following major elements. 1. A pipeline receiving the fumes from the fume gases channel, block number 12. 2. Electrostatic filter. 3. Bag filter. 4. A system dosing chemical additives to fume gases. 5. A building with devices that control the installation. 6. A fan that pumps the flue gases back to the channel of block number 12. 7. A pipeline sending the fumes from the verification installation to the fume gas channel of block number 12. Mercury is most often removed together with other gas and solid impurities. In the applied method, mercury is captured from flue gases. Then, the most effective and preferred for its removal are adsorption methods. Sorbents are applied in the dust extraction systems, also in installation of flue gas desulfurization. they are introduced into the flue gases or pose a material of fluidized deposits. The adsorption methods are characterized with high effectiveness regarding the relationship of mercury pairs towards high amounts of various adsorbents. Removal of mercury from flue gases may be provided through injection of an adsorbent to the fumes, and then through removing the used adsorbent in dust extraction systems, electrofilters, or fabric filters. Mercury adsorption also takes place during transmission of a flue gas stream through an adsorber deposit of proper granulation. Active coal is most often used for adsorption of gas mercury. Other sorbents applied for reduction of mercury emission include calcium and sodium sorbents, as well as loams, zeolites, lime, and lime silicon sorbents. The effectiveness of the process of mercury adsorption depends on the temperature, composition of flue gases, contact time of the flue gases with the sorbent, physical and chemical qualities of the sorbent surface, and the concentration of mercury itself in the flue gases. All of these dependencies will be examined at a measurement post in the Łaziska power plant. The effectiveness of adsorbers in removing mercury from flue gases may be evaluated through impregnation with sulfur, noble metals, iodine, chlorine, and bromine. Through simultaneous application of desulfurization and dust extraction of flue gases, together with injection of the sorbent in a form of active coal, the achieved effectiveness of mercury removal remains at the level of 95%. The method of examination of content and reduction of mercury from flue gases applied in the Łaziska power plant will allow accurate examination of the chemical parameters of the combusted coal and a selection of optimum parameters of work of the installation for mercury reduction. A ceremonial handover of operation of the installation for examination and capturing mercury from flue gases in the Łaziska power plant took place on the 24th of June 2014 with the participation of the Łaziska power plant engineering staff, representatives of the University of Science and Technology in Krakow, representatives of the main contractor of the installation, the Rafako company, and board members of Tauron Production. The Tauron Group wants to make a significant contribution to the widespread use of these methods and possibilities when it comes to the capture of mercury from exhaust gases. As for science and business, due to these investments, we will be able to unequivocally define our direction for the future. The present conducted works will allow to develop a full technological project reducing flue gas emissions, which will pose another great leap towards improving the ecological level of coal combustion as the main fuel in the Łaziska power plant and other power plants that belong to the Tauron Production Group. Examinations performed by Tauron Production in the Łaziska power plant will also have a significant influence on development of Polish energetics, which to a great majority is powered by hard and brown coal.